The 10,000 cycle threshold. Figure 03 just completed its 10,000th autonomous sheet metal placement on the BMW Spartanburg assembly line without a human operator in sight. This is not another pilot program or a staged laboratory demo designed for a venture capital slide deck. It is a paid commercial deployment where the robot is billed at $25 per hour. For years, the industry focused on making robots talk using large language models. But BMW does not need a robot that can explain how a car works. It needs a machine that can place a chassis bracket with 5mm precision every 60 seconds for 10 hours straight. We have finally moved past the era of the Chatty pilot and into the age of high-rate silicon labor. And the speed of this shift comes down to a fundamental change in how the robot actually thinks. The death of the Chatty robot. Most early humanoid successes were actually failures in disguise because they relied on large language models for control. An LLM might be great at writing poetry, but it is physically slow. If a robot has to wait half a second for a cloud server to decide how to move its arm, the machine becomes a safety hazard or a bottleneck. Figure's CEO Brett Adcock recently pivoted the company away from these external AI partnerships because language is now the easiest part of the puzzle. The hard part is high-rate control. BMW realized that a robot with a high IQ but slow reflexes is useless on a line that moves at a fixed takt time. They needed to solve for latency, not for vocabulary. This realization led to the development of the Helix O2 system, which treats physical movement as a single unified calculation. This architectural shift is what allowed these machines to finally earn a paycheck on the factory floor. Inside the 1 kHz loop, the technical secret behind Figure 03 is a control loop running at 1000 Hz. Think of this like the robot's nervous system firing 1000 times every second to micro-adjust its balance and grip. Previous generations like Figure 02 struggled with the 20 Hz vision bottleneck, which is why they looked hesitant and jittery. The new Helix system replaces over 100,000 lines of hand-coded C++ with a single neural network trained on joint-level human motion data. It does not think about where to put its foot, it simply predicts the next millisecond of movement based on the pixels it sees. This allows the robot to handle the ergonomically punishing tasks that humans hate, like loading heavy sheet metal into welding fixtures. By operating at the speed of human biology without the fatigue of human muscles, the humanoid has reached a level of industrial reliability that was considered impossible just 18 months ago. The efficiency of silicon labor. The decision for BMW to deploy 40 units this month was driven by a brutal piece of math. In the Spartanburg plant, human turnover for repetitive lifting tasks is a constant drain on productivity. Figure 03 operates on a robot-as-a-service model, which eliminates the massive upfront cost usually associated with industrial automation. At $25 an hour, the robot is already price competitive with human labor in the United States once you factor in insurance and training. But unlike a human, the robot does not need breaks, and its performance does not degrade during a 10-hour shift. There is a common argument that humanoids are too complex for a factory floor compared to traditional fixed arms. However, a fixed arm cannot walk over to a different workstation when a line changes. The humanoid provides the flexibility of a human with the predictability of a computer. This makes it the first general-purpose tool that can be dropped into an existing factory without rebuilding the entire building around it. The end of the pilot era. The transition from Figure 02's laboratory tests to Figure 03's live commercial operations marks the official death of the humanoid hype cycle. We are no longer debating if these machines can work. We are now measuring how many parts per hour they can move versus a human associate. By shifting from slow LLM pilots to high-rate neural control, Figure has turned the humanoid into a predictable industrial commodity. For engineers and factory operators, this means the focus has moved from AI safety research to fleet management and mechanical uptime. If you are waiting for a futuristic moment where robots walk into every home, you are looking in the wrong direction. The real shift is happening right now in the body shops and assembly lines, where the cost of a robot hour has finally dropped below the cost of a human hour. This is no longer a technology story. It is a logistics and manufacturing standard. Keep your eyes on the deployment numbers at the Leipzig plant this summer as the first European units begin their shifts. That will be the signal that this labor model has reached global escape velocity. Subscribe for more.